4.2, solving quadratic equations by graphing. So when it's saying solving, when you solve an equation, you solve for x, correct? All right, so the solutions, or when we solve quadratics, if we're solving for x, then those solutions are going to be the actual x-intercepts of the parabola, because we're solving for x. So where does it cross? The x-axis. Okay, those x-intercepts are also referred to as zeros of the function because the y value is always 0, or the output is always 0. And they're also referred to as roots. So make sure you understand anytime you hear the terminology of solutions, zeros, or roots, it's all referring to the x-intercepts of a quadratic. Okay, and because quadratic equations have x squared, we have a possibility of having two solutions, one solution, or no solutions. So let's see what those look like. Remember, I said that the solutions are where they cross the x-axis. So notice, so if it has one solution, excuse me, my parabola is literally going to cross or touch the x-axis only one time, which means it has to be the vertex. If I have one solution, it's going to be where the vertex is of the parabola. If it has two solutions, it would look something like this. It crosses the x-axis 2 times. And if there's no solutions, then it literally doesn't cross the x-axis at all. Okay, so there's 3 possible answers. One solution, which is always the vertex. 75% of the time it'll have 2 solutions, and then we also have no solutions. So let's look at an example of each one of those. Let's start with the most common, which is 2 solutions. Okay, here's my first problem. Does everybody see it? Solve by graphing. Okay, notice this equation, instead of being equal to y, is equal to 0. Because x-intercepts always have a y value of 0. So these equations, instead of being equal to y, I'm just replacing that y with 0. So I'm setting the equation in standard form equal to 0 and solving for x. But this time we're doing it by graphing. So if I plug this into the calculator and look at the graph, I have this. And you can see that it crosses the x-axis at, looks like, -1 and +4. So this one has 2 solutions. X equals -1 and x equals 4. Okay, let's look at that again. When I look at the graph, it's the x-intercepts, or where it crosses the x-axis, so it has 2 solutions, -1 and +4. Now, if I plug these values into x, they're also going to be equal to 0. So -1 squared minus 3 times -1 minus 4. If I simplify this, as you can see, is equal to 0. If I do the same thing with 4 squared minus 3 times 4 minus 4, 16 minus 12 minus 4 is equal to 0. Okay? So, besides just finding the x-intercepts on a graph, I can also find it in a table. This particular picture from the book gives you a vertical table instead of a horizontal table like it is in your calculator. But remember, where would the solutions be? Well, where are the x-intercepts going to be? It's where y is 0. So where y is 0, you can see x is equal to -1, and another 0 of the function, or where y is 0, x is equal to 4. Okay, and that's why these are called zeros of the function. When I solve it, x equals -1 and x is equal to 4. So that would be 2 solutions. Now let's look at one that has 1 solution. Okay, solve by graphing. But first of all, this is not in standard form at all, and it has to be set equal to 0, okay? That's the big idea, concept for this particular lesson. In order to solve this by graphing, I have to find the x-intercept where y is 0. So these all have to be put in standard form where y is set equal to 0. So I'm going to rearrange my terms. I'm going to move them all to the same side of the equal sign so that one side is 0. Then look at the graph. So I'm going to subtract 14 over here. And I'm going to add x squared to this side. Okay, so now this side is 0, which is good. I'm going to put the x squared term first. Then it looks like minus 6x. And then 23 minus 14 is 9. This is now in standard form. I moved these. Again, I moved these terms all to the same side of the equal sign so that one side is 0. And I wrote it in order. X squared minus 6x, and then that sum is positive 9. Now when I look at the graph, notice it has one solution. It's right here. It is the vertex. It's at x equals, looks like x equals 3. And you can see that value in the table as well. Again, I'm looking for that in the y column. And remember, if it's in the calculator, the y column is the far one to the right, but this is a vertical table. So the y value of 0, which means my solution is x equals 3. Oh, I'm so sorry. I did not mean to do that. I'm looking for the y value of 0. X is equal to 3. All right, and no solutions. Really simple. Looks like this. It literally doesn't cross the x-axis at all. Okay, there is an equation for it. This particular example in the book didn't give me the equation. But if I graphed it, it would not cross the x-axis. You would say there is no solution, no real solution. All right, the second kind of problems in this lesson are if you do not have okay, give me a second. Is by estimating the roots. This is just asking you a little bit different way. Oh, I'm so sorry. It says, solve x squared minus 6x plus 4. Notice this is already set equal to 0 by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. So now we're just going to estimate them. Okay, so they're not whole numbers. They're not integers. These roots are not really easy to see on the graph like these are. They're not nice integers. So we're first going to estimate them from a graph or a table, and then I'm going to show you on the calculator how to actually calculate them. Okay, so let's look at the graph here. Again, the roots are the x-intercepts. So it's this and this right here. So which consecutive integer, so which two values does this lie between? So this particular root or x-intercept crosses between, looks like 0 and 1. Then the other root or x-intercept is, looks like 1, 2, 3, 4, 5, between 5 and 6. So we know they're not integers. I can't tell exactly where they are from the graph, but I can estimate them to fall somewhere between 0 and 1 and 5 and 6. Okay, well, how would that look if we were looking in the table? Remember last time we looked for the zeros in the y. Okay, so let's look over here. Look at this table. Do we have any zeros in the y anywhere? We don't. Well, I know if the y value is 4, and then the next point, the y value is -1, 0 has to be somewhere in between here, correct? If exact roots cannot be found, state the consecutive integers between which the roots can be located. I know that there's a 0 in here somewhere between 4 and -1, which means the consecutive integers for x, my answer would be an x value somewhere between 0 and 1. Same thing, I'm looking for a sign change. Let's see, sign change, sign. Oh, right here, look. I'm looking for a sign change. So somewhere between these two consecutive points, consecutive, 5 and 6 are consecutive, somewhere between here, the y value is going to be 0. Okay, so where does that fall? Somewhere between 5 and 6. Remember, that's what we came up with over here. So I'm either looking for a sign change between 4 and -1, because I know somewhere in between here, somewhere in these decimals, 0.1, 0.2, 0.3, 0.4, 0.5, if I expanded this table, then the y value is going to be 0 somewhere in between here, okay? Which means my root, or it would cross the x-axis somewhere between 0 and 1. And same thing over here. I found the sign change on the y, which means there's a 0 somewhere between there. So my answer is a root between 5 and 6.